in this class. Actually, this is the September 1st, right? Clear. So, maybe I planned in the September I have to start the thermodynamics and statistical mechanics. From thermodynamics statistical mechanics onwards, I will strictly follow to give the question papers also to you, right? Quantum mechanics, this is the last to least subject, that is the Dirac equation. Under the relativistic quantum mechanics, we have two things are there. One is Klein-Gordon equation, another one is the Dirac equation. Maybe Klein-Gordon equation only one class I took and I wind up that one. So, Dirac equation is very important, maybe you read or you did not read. So, whatever it may be. So, some more one or two classes I have to take because this is the third class. Big class I did not take because small thing you have to learn, because I have some work. So, that is why I am able to make it as a PPT is a bigger one. So, maybe if it is possible tomorrow I have to wind up this Dirac theory. So, after finishing this we have to enter into the semi-classical theory of radiation. This semi-classical theory of radiation is the application of the time dependent perturbation theory. Already I told under the time dependent perturbation theory. So, we are discussing about the semi-classical theory of radiation also. But even though syllabus is quoted, so people may ask why teacher is not teaching this one. So, that is why I have to take 1 and 2 classes I have to take. Actually, I put the target up to the 90 classes. Within the 90 classes I need to finish. So, today is the 86th class. Within the 4 classes I need to finish. 2 classes I have to take the semi-classical theory of radiation. 2 classes I will teach to the Dirac equation. So, today I am going to teach about the Dirac equation in covariant form. How we have to derive the Dirac equation in covariant form. So, there is a gamma matrix is there here. So, that gamma matrix what are the properties of the gamma matrix, how we have to introduce the gamma matrix. So, those things we have to learn here. So, Dirac equation in covariant form, you know the Schrodinger wave equation. The Schrodinger wave equation E psi is equal to S psi. So, you know that E psi is equal to S psi, but you know the Dirac Hamiltonian. So, what is your Dirac Hamiltonian? So, this is the Schrodinger wave equation. So, Dirac Hamiltonian H is equal to C into alpha dot P, C into alpha dot P plus beta MC square. This is the Dirac Hamiltonian. Already from 2 days onwards we are discussing about the Dirac Hamiltonian. So, now alpha and so P are both are components, that is a dot product you have to take and you have to expand. You will get the Dirac Hamiltonian expression alpha x into Px, alpha x into Px, alpha y into Py plus alpha z into Pz, alpha z into Pz. So, plus beta MC square you are going to get it. This is the beta MC square you are going to get, right. So, in terms of you have to write that one. Suppose you able to take in terms of alpha x is equal to alpha 1 you have to consider. Let you have to take it as a alpha x is equal to alpha 1, alpha y is equal to alpha 2, alpha z is equal to alpha 3 you have to take. So, therefore, what is going to happen, you able to see here, you have to write it is alpha 1, alpha 2, alpha 3 you have to write. So, therefore, your H is equal to that Dirac Hamiltonian is equal to, we have to take it as the summation of k is equal to 1 to 3, summation of k is equal to 1 to 3, alpha k you have to write it is, that is the alpha k, C also you have to take in front of C alpha k you have to take. So, the differentiation operator you have to write it is that P is equal to minus I h cut into del, minus I h cut into del plus beta MC square you have to write it. So, this is the Dirac Hamiltonian you have to write. So, this Dirac Hamiltonian I have to rearrange this minus h cut you have to bring into outside, minus I h cut into, we have to write it is summation k is equal to 1 to 3 summation k is equal to 1 to 3 c into alpha k into, so your del is a operator. So what is your del? So del is equal to I into dou by dou x. So I into dou by dou x plus j into dou by dou y plus k into dou by dou z. You have to write it is, so this is very important one, you have to take plus beta mc square you are going to write it is. So that is the beta mc square you have to write. So now we have to introduce a new matrix we have to introduce. So what matrix you have to introduce? You are introducing the new matrix. Here you have to introduce, which one you have to introduce? Introducing a new matrix we have to introduce. Introducing the new matrix you have to introduce. Then what is going to happen? You have to see a new matrix you have to introduce. That matrix is gamma you have to take. So that matrix is the gamma, new matrix element you have to introduce. So therefore gamma mu is equal to, we have to write it is gamma mu is equal to minus I beta into alpha mu, we have to write it is alpha mu is a, you have to take it as a alpha I or alpha mu you have to write. So which one you able to take it as a alpha mu you have to write it. So where mu is equal to, we are going to write it as, we are going to take it as mu is equal to 1 comma 2 comma 3, because these are only 3 matrices are eligible, but gamma 4 is equal to, so beta you have to write it is gamma 4 is equal to beta. So minus I beta, so gamma 4 is equal to beta you able to take. So now you have to introduce this one new matrix element you have to introduce. So after introducing this new matrix element, you have to substitute in the above expression, you have to substitute. So that is E psi is equal to S psi, these are you have to substitute in the Hamiltonian equation, you have to substitute. A is the energy operator, that is I h cut into dou by dou t of psi, which is equal to Dirac Hamiltonian you have to write it is. So what is your Dirac Hamiltonian? Minus I h cut into, your Dirac Hamiltonian is minus I h cut into say, minus I h cut into say summation of k is equal to 1 to 3, summation of k is equal to 1 to 3 alpha k, you have to write it is dou by dou x k, you have to write it is dou by dou x k. So plus beta mc square, we have to write it is a beta mc square into psi, you have to write it is that this is the h value you are going to write it. So now you have to write multiplying the equation, multiply. So with what parameter you have to multiply? So multiplying by beta matrix on both sides, multiplying by beta matrix on both sides you have to multiply. So what is going to happen? You have to see multiplying the beta matrix on both sides, multiplying the beta matrix on both sides. So that beta matrix you have to multiply on both sides, what is going to happen? I h cut into beta, I h cut into beta, so dou psi is divided by dou t, dou psi is divided by dou t, which is equal to, we are going to multiply with so minus I h cut into beta, minus I h cut into beta, summation c into summation k is equal to 1 to infinite alpha k into, so dou by dou x k, dou by dou x k plus beta into beta, so beta square into mc square into psi, you have to write it is beta into mc square into psi. But you know that yesterday we are discussing the properties of alpha and beta matrices, beta square is equal to 1, and we are defining the gamma k is equal to, how we have to define minus I beta into alpha k. So, we are introducing the new matrix, that matrix we have to introduce. So, therefore, you have to write it is I h cut, you able to take it as a I h cut into beta dou psi by dou t you have to write, which is equal to, here you have to write minus I is there. So, beta also is there, alpha k also is there, alpha k also is there. The rest of the things I have to write here. C h cut is there, C h cut I am writing here. K is equal to 1 2 3, k is equal to 1 2 3. Instead of this minus I h cut and alpha k, we are introducing the another matrix gamma k we are introducing. So, that is dou by dou x k plus m c square plus m c square, because beta square is equal to 1 into psi, you are going to get it. Clear? So, this is very important thing, expression you are going to get. So, again you have to rearrange this expression. How we have to rearrange this expression? So, this expression you have to divide it with h cut c on both sides. So, what is going to happen you have to see. So, you have to write first that expression, you have to write it is I h cut into dou psi by dou t, I h cut into dou psi by dou t is equal to, as it is I am writing that expression, C h cut or h cut c, you have to take it as a C h cut into summation k is equal to 1 2 3 gamma k into dou by dou x k. So, plus m c square into psi, you have to write it is. This is the m c square into psi. So, this expression you have to divide, dividing with what? So, dividing with h cut c on both sides, h cut c, dividing with h cut c on both sides, you have to divide that expression. So, what you are going to get it? So, you are going to get I h cut is divided by h cut c, I h cut is divided by h cut c is divided by dou psi by dou t is equal to, you have to write it is h cut c is divided by h cut c, summation k is equal to 1 2 3 gamma k dou by dou x k plus m c square is divided by h cut c into psi is there. So, c get cancelled. Now, you have to write h cut c get cancelled, h cut also you have to get it get cancelled, you have to write it. So, therefore, what we are going to write it is I by c into dou psi by dou t, which is equal to what we have to take here, summation of k is equal to 1 2 3 gamma k dou by dou x k plus m c is divided by h cut into psi, you are going to get it. M c is divided by h cut into psi, you are going to get. Now, you have to multiply this expression, you have to multiply. So, with multiply with I and divided with I, you have to take. So, multiply with I and divided with I. So, what is going to happen you have to see, I into I square you are going to get. Here beta also is there, no, beta also is there, into beta you are going to get it. So, therefore, what you have to write it is minus I into I square minus beta is divided by I into c, minus beta is divided by I into c, you have to write it is. So, dou psi is divided by dou t, which is equal to, dou psi is divided by dou t, which is equal to summation of k is equal to 1 2 3 gamma k dou psi by dou x k plus m c is divided by h cut, as it is you have to write this in this expression. But you know that, so what you have to know? So, let you have to remind that x4 is equal to, you know that the fourth component of the position is equal to ICT, the x component of the position is equal to ICT. So, therefore, what we have to write from this, similarly you able to write it as a, so we have to take So dou by dou x4 is equal to dou by dou ICT, you have to write it is. So therefore dou by dou x4 is equal to, we are going to write it is 1 by IC into dou by dou t, you are going to substitute 1 by IC into dou by dou t. So what we have to write it is 1 by IC into dou by dou t. How you able to take 1 by IC into dou by dou t, which is equal to dou by dou x4, we have to write it is. So now you have to substitute in that expression, you able to take, so what we have to write it is minus beta into dou psi is divided by dou t is all divided by IC, which is equal to, what is our expression? Our expression is we have to write it is summation of k is equal to 1 to 3 gamma k dou by dou xk plus mc is divided by h cut, mc is divided by h cut into psi. Now you have to substitute this dou by dou x4 is equal to 1 by IC into dou by dou t, 1 by IC into dou by dou t, you have to substitute. So therefore beta into dou psi is divided by dou x4, we have to write it. Beta into dou by dou psi is divided by dou x4, which is equal to, we have to write summation k is equal to 1 to 3, summation k is equal to 1 to 3 gamma k dou by dou xk plus mc is divided by h cut into psi, mc into is divided by h cut into psi, you have to substitute. So therefore what is going to happen, you have to take bring this one to here. So what is going to happen, summation of k is equal to 1 to 3 gamma k dou by dou xk plus beta into, so dou by dou x4, so plus so mc is divided by h cut into psi is equal to 0. So if you have to bring, you able to get it. So this is the 3 components are there, this is the 1 component is there. So therefore gamma 4 is equal to beta, already we introduced. So x4 is equal to, that is the gamma 4 component is there. So therefore this expression we have to write it is summation mu is equal to 1 to 4, summation mu is equal to 1 to 4 gamma mu dou by dou x mu, we have to write it is dou by dou x mu plus mc by h cut into psi, which is equal to 0, mc by h cut into psi, which is equal to 0. So therefore what we have to write here, once you have to say summation mu is equal to 1 to 4 gamma mu dou by dou x mu plus mc is divided by h cut into psi, which is equal to 0. But you know the properties of the Kronecker delta properties, you have to write it is. So what is that? Summation of mu is equal to 1 to 4 gamma mu dou by dou x mu is equal to, we have to write it as a gamma mu dou by dou x mu, have to write. So not only that, so you are going to take it as a dou by dou x mu is equal to, so dou mu also you have to write, dou by dou x mu is equal to gamma mu is equal to, we are going to take it as a gamma k comma gamma 4, you have to write. This is the 4 vector form you are going to take it as. So therefore our expression will become, so our expression will change gamma mu dou by dou x mu plus mc by h cut, so that summation have to dropped. So therefore into psi, which is equal to 0, into psi, which is equal to 0. But you know that gamma mu, so this is the Kronecker delta of mu a plus mc is divided by h cut into psi, is equal to 0. This expression we call it as a Dirac equation in terms of the covariant form. Which form it is? Dirac equation in terms of the covariant form. Dirac equation in terms of what? In terms of covariant form. Dirac equation in terms of the covariant form. This is very important. Gamma mu. So dou mu plus mc by h cut into psi is equal to 0. So this expression is a very important expression. Now you have to listen. So what is the note of this? So this equation we call it as a, which equation? That is gamma mu dou mu, gamma mu dou mu plus mc is divided by h cut into psi plus mc is divided by h cut into psi is equal to 0. So this expression is a covariant form of, this expression is the covariant form of the Dirac equation. So the Dirac equation is relativistically invariant. The Dirac equation is relativistically invariant if the state vector transforms under the low-range transformation in the prescribed form. If it is does not transform in the required way or prescribed form, it is possible to construct the low-range invariant from psi. We have to construct the low-range invariant and you have to apply the same low-range expression in terms of the momentum operator. The low-range equation in terms of the momentum operator, the covariant form, you have to take it as a gamma mu p mu. This is the momentum p mu minus I mc into psi. So this is which is equal to 0. So this is the low-range momentum operator covariant form of the Dirac equation. So not only that, so one more representation also you have to give as a contravariant form you are going to give, or so we have to take one more representation also is there. So what is that representation? I into gamma mu, I into gamma mu, you have to write it as a dou mu, I into gamma mu dou mu minus m into psi is equal to 0. So which one we have to take it as here? H cut is equal to, you have to take it as a 1 and c is equal to 1, then only you have to apply this one. So otherwise you able to get it as a c, you have to get it here, h cut also you able to get it. Clear? So now dou mu is equal to, what we have to write here? So dou by dou mu is equal to, so dou mu is equal to, or dou by dou mu is equal to, we able to take it as a dou mu is equal to, we have to take, so what we have to write it is dou by dou t, dou by dou x, dou by dou y, dou by dou z, you are going to write it is dou by dou x, dou by dou y, dou by dou z, you have to take, so you will get the another representation of the covariant form of Dirac equation in terms of, this is the in terms of the momentum, this is in terms of another representation is there. So that another representation is I gamma mu dou mu minus mc means you have to write it as a c is equal to 1, you able to get it as a, that one you have to write it is. So these are the three equations we are learning. So what is that three equations? Once you have to see, first equation you have to take, so three varieties of the covariant equations we are learning. The first equation is gamma mu dou mu, gamma mu dou mu plus mc is divided by h cut plus mc is divided by h cut into psi is equal to 0. This is the first one. What is the second one? In terms of the momentum we are going to write it is, so what is the momentum? Gamma mu p mu, gamma mu p mu minus I mc into psi which is equal to 0. This is the second expression we are going to write it is. So what is the third expression you have to say? The third expression you able to take it as a I h cut into, so gamma mu dou mu, gamma mu dou mu minus mc into psi is equal to 0. So here you have to take it as a, so c and h cut you have to take it as a, h cut is equal to 1 and c is equal to 1, you are going to write it is. So therefore I gamma mu dou mu minus m into psi is equal to 0, you are going to get it. This expression I am giving. So these three expressions also you are going to take it as a covariant form of the Dirac equation or Dirac equation covariant forms. Clear? Here we are introducing the one new matrix. So that matrix is the gamma matrix. What are the properties of the gamma matrix? These are very important. So I have to define the gamma matrix once. You have to see the first property, you able to take the gamma matrix is equal to gamma 1 is equal to, we have to write it as gamma 1 is equal to, you able to define 0 minus I sigma x, I sigma x minus I sigma x, I sigma x 0. This is the 4 cross 4 matrix, you able to get it. Similarly gamma 2 is equal to, so gamma 2 is equal to, also you have to write it as 0 minus I sigma y, I sigma y into 0, right. This is another one. So gamma 3 is equal to, also you have to take it as a 0 minus I sigma z, I sigma z into 0, you are going to get. This is the gamma 3. So not only gamma 1 and gamma 2, gamma 3, gamma 4 is equal to, you are going to get it as a, this is I 0, 0 minus I, you are going to get it. This is the gamma 4 matrix. But you know that sigma x is a Pauli spin matrices, you know that. So that is the 0 1 1 0, sigma y is equal to 0 minus I 0, sigma z is equal to, you are going to write it as sigma z is equal to 1 0, 0 minus 1. This is the Pauli 3 spin matrices are there. So these are the gamma matrices you have to remember. So not only this, so I have to take some another representation of the gamma matrices, you have to take another representation, you able to take another representation, you have to take it as another representation, you have to write. So another representation of gamma matrices, you have to see what are those another representation of the gamma matrices, you have to take it as a, so gamma 0 you have to take it as a covariant, contravariant I have to write it is. So gamma 0 is equal to, you are going to write it as I 0, so 0 minus I 0, 0 minus I, which is equal to, already we are defining, that is going to take it as a beta. So therefore gamma I is equal to, we have to represent as a gamma I is equal to 0 sigma I minus sigma I 0, we are going to write it is, where sigma I is the, what are those things, Pauli spin matrices, sigma I is Pauli's spin matrices, you have to write it is, sigma I's are the Pauli spin matrices, you are going to write it is. So not only that, so you are going to take it as a, some more properties you able to write. So what is that, the second property you have to take, so gamma k, so gamma k is equal to gamma k dagger, so gamma k is equal to gamma k dagger, means gamma matrix is the Hermitian matrices. Which matrix it is? It is a Hermitian or adjoint Hermitian matrices. This gamma matrix is adjoint, self adjoint matrix also we call it as. So now the third property you are going to take. So what is the third property? Gamma k square is equal to minus I4, you have to write it is. So gamma k square is equal to minus I4. So this is the 4 cross 4 matrix, that is I4 means. So gamma 1 into gamma 2, plus gamma 2 into gamma 1 is equal to 0. You have to write it is. Now the fifth property you have to take it as a gamma 4. So gamma 4 into gamma I, so which is equal to 0. Gamma 4 into gamma I is equal to 0. So not only that, so you are going to take it as a sixth one, you have to write it is gamma 1 in gamma 1 you have to take. So what is the gamma 1? Gamma 1 you have to write it is, that is the 2i. So therefore I have to take the formula gamma mu comma gamma v, you able to take it as which is equal to 2 into Kronecker delta mu v into I. So where Kronecker delta mu v is equal to, you have to take it as a 1. When it will become as a 1 at mu is equal to v, so it will become as a 0. At mu is not equal to v, it is going to become as a 0, you are going to get it. Clear? So now not only that, so you have to take it as a, so very important expressions you are going to get. So gamma k square or gamma 1 square, gamma 2 square also you are going to get it, gamma minus I4 you are going to get. So not only that, so you have to write it as one more representation, you able to take it as a, so 7 gamma I, so is equal to gamma 0 into alpha I, so which is equal to, you have to take it as a gamma I you are going to get. So gamma 0 into alpha I, so what is your alpha I? So you have to multiply, you are going to get it, that expression you are going to get it. Clear? So these are the properties of the gamma matrices. So these gamma matrices you have to remember. Clear? So this is the covariant form of a Dirac equation. So very important. Now in 2019 there was one question in set examination. What is that question? You have to see which of the following is a first order differential equation. This Klein-Gordon equation is the second order differential equation. The second order differential equation in time and space coordinates. So in time and space coordinates, this is the second order differential equation. Second order in time and space differentials. Time and space differentials. So those are the second order. Schrodinger relativistic equation is nothing but a Klein-Gordon equation. So the same name is there. Now inhomogeneous wave equation also, this is the second order in time and space coordinates. In time, second order in time and space coordinates, you have to write space differentials. Time and space differential, this expression also second order. Now you have to take, so the Dirac equation is correct. So the Dirac equation is a linear equation. So linear equation in what? In time and space coordinates. So like that, so the time and space differentials, this is the linear equation. What is the first order differential equation? Dirac equation is the first order differential equation in space and time differentials. Clear? So that is very important. Under the space, that is the del, under the time, that is dou by dou t. Clear? So today is enough, and maybe tomorrow I have to take some more interesting topics. I will discuss to you how to apply this Dirac equation in electric field and magnetic field, and some more problems also we are going to discuss. Maybe so 2 classes I am going to discuss in the Dirac equation, 2 more classes I am going to discuss in the semi-classical theory of radiation. So total 4 classes I need to take. Within 4 classes I need to finish the entire the quantum mechanics portion. Means 4 days you have to wait it. So after taking the quantum mechanics from statistical and thermodynamics onwards, morning and evening I will take the class to you. So please concentrate and practice it. Without practicing we are unable to remember all these things. So much of content I gave in the quantum mechanics. As much as possible the maximum derivations I derived, sometimes I gave the direct formulas also. Whatever I am giving, so at least 4-5 times you have to revise, then only you able to get the some idea, not perfect idea. Clear? So thank you so much. So please practice it.